9-4 parabolas in the coordinate plane. All right, so example 1, what is the set of points that are equidistant from the graph of the equation y equals -2 and the point 0, 2? Okay, so ignore that, that shouldn't be on there. All right, so the first thing that we want to do is draw a line that is perpendicular to y equals -2. Okay, so I'm going to draw a line that's perpendicular. I'll do a solid line. Then I'm going to go ahead and draw a second line that's perpendicular. So that just means it's forming a right angle. Okay, so the first step we did was to draw a line that is perpendicular. Our next step is to find a point that is equidistant from 0, 2 and y equals -2. Okay, so if I'm looking for a point that is equidistant from 0, 2 and y equals -2, that point would be on for this one at the origin. So this is 2 away from our point 0, 2 and also 2 away from the y equals -2. After we've found that first point, our next step is to find other points. And again, they need to be equal distance from the 0, 2 and the y equals -2. All right, my next point would be 4, 2. And that is 4 away from the original point and from the y equals -2. Likewise, across the axis, -4, +2. Then I will create a curve. I'm going to connect those points to create a curve. Okay, that curve that I just created is called a parabola. Okay, let's look at our try it. The set of points equidistant from 3, 5 and the line y equals 9. And they're telling us it is also a parabola. Okay, so first thing we're going to do is plot the points, so 3, 5. And then our y equals 9. Okay, A, what is the vertex of our parabola? Well, we need to create the parabola. Okay, so we're going to draw some perpendicular lines. Get that straighter. All right, we want to find a point that is equidistant from the point they gave us and our line. So that's going to be right here. And that is our vertex. So our vertex is going to be at 3, 7. We want to find additional points that are equidistant from the original point in the line. Okay, so this one is 4 away from the line and 4 away from the point. Same with this one. I'll connect those to create a parabola. All right, B, describe the graph of the parabola. And our parabola is opening downwards and has a vertex of 3, 7. Okay, example 2. What is the equation of a parabola? A parabola is a set of all points in a plane that are the same distance from a fixed point, point F, the focus, as they are from line D, the directs. Okay, so the distance between our point and our fixed point, that focus, and our line, those should be equal to each other. So PF should equal PA. Okay, so those distances, the length of those should equal each other. So I'm going to use the distance formula, and I'm going to plug in PF and set it equal to PA, the distance for PA. Okay, I'm going to simplify. X minus x is 0, so it's going to cancel that out. The square roots will cancel each other out. I'm going to go ahead and distribute the squares. My y squareds cancel each other out along with the p squareds. So I'm left with x squared minus 2py equals 2yp. I will add my 2py over, which I can add to this one if I just rearrange my p and my y. So I'm going to be left with 4py. And I want to solve this in terms of y, so I'm going to divide both sides by 4p. So I end up with 1x squared, 1 over 4p x squared equals y. Okay, let's look at the triad. What expression represents the distance between the focus and the directrix? Okay, so our focus and our directrix, we're going to plug those into the distance formula. Okay, and our H for our directrix is just H because we are just going to go straight down. Okay, H minus H squared is going to cancel out. Go ahead and get rid of the extra set of parentheses. This should be a plus P. My K's will cancel out. I'm going to be left with P 2P squared. Well, the square root of a square, that cancels out, so I'm just left with 2P. All right, so our equation of the parabola. So we have an equation for when our vertex is the origin, and then we have an equation for when they tell us a vertex. All right, we're going to look at example 3. What equation represents the parabola with a focus 5, 5 and a directrix of y equals 1? Okay, the first thing we're going to do is plot the 5, 5. And then the y equals 1. Go ahead and find our vertex. So this was my focus, the 5, 5. My vertex then is 5, 3. Okay, my vertex is not the origin, so I'm going to be using my vertex formula or equation. So I'll come down here and plug in the information we know. So y minus 3 equals 1 over 4 P, which P is the distance between the vertex and the focus. So that would be 2. And then x minus h, which h is 5 squared. All right, we'll go ahead and simplify. We would be adding our 3 over, so I'm left with y equals, I'm going to simplify the 1 over 4 times 2 to get 1/8. And then we brought that 3 over. Okay, so that is my equation for the parabola. Let's look at B. We're going to use the graph above to create a parabola with a focus of 5 and a directrix of 1, where the equation, and then they gave us the equation. Okay, and that's the same equation that we just created. So we are going to graph the parabola that we started graphing above. I'm going to go ahead and change my color so we can see the difference here. So I want to find some additional points. So I'm just going to pick a couple of x points. So 1, 3, and 8. And then we're just going to plug those x points into our y equation. So my x is 1 minus 5. Okay, once we're done with that, we will solve it to find x and y. I'm going to go ahead and write out the rest of these first. All right, when x is 1, I will end up with 5 for my y. When x is 3, I will end up with 3.5 for my y. When x is 8, I will end up with 4 and 1/8. Okay, so now I'm going to come above and I'm going to graph those. So 1, 5, right here. 3 and 3.5. 8 and 4 and 1/8. Now we're just going to connect those along with the vertex to create our parabola. Okay, let's look at our triad. What equation represents the parabola with a focus of -1, 4 and a directrix of y equals -2? So we'll go ahead and plot those. So that's our focus. So I want to find my vertex. We're finding a point that is equidistant from the focus and our directrix. So that would be at -1, +1. Now I can take that and plug it in to our equation. All right, the distance between our focus and the vertex is 3. Go ahead and simplify. All right, B. What equation represents the parabola with a focus of 3, 5? And then it has a vertex of 3, -1. Okay, so this time they gave us our focus and a vertex. They didn't give us our directrix, but we don't need it. We can find it. My P would be 6, so my directrix would be 6 below the vertex. So at y equals -7. So then I plug that into the equation. My P was 6. And that is my equation for a parabola. All right, example 4. A cross-section of a satellite dish is a parabola with the feed horn at the focus. how long do the braces holding the feed horn need to be? Okay, so let's kind of sketch this out in a coordinate plane. Okay, so I have my origin here. Our feed horn, the triangle for that, is a little bit above the axis. Okay, we've got our feed horn at the very top, and then it's creating the triangle. Okay, so they told us the entire height of the satellite dish is 60 up to the feed horn. So this coordinate would be 0, 60. Let me zoom in. So this would be 0, 60. And then our feed horn has a height of 10, so this would be 0, 70. The entire diameter is 150, so that means the radius would be 75. So this coordinate would be 75, and then whatever the height is. This coordinate here would be 75, 0. Okay, going the opposite direction, this would be negative 75, 0. Oh, negative 75h. Then negative 75, 0. This right here would be 0h. Okay, so we've got it sketched out. Now we can start working on solving this. So our first step would be to write our equation. Okay, this is starting at the origin, so we're going to use our equation where our vertex is at the origin. So y equals 1 over 4p. Our p is 60. And then x squared. Go ahead and simplify this. Okay, we're going to try to find the height here. So we're going to plug in the 75 for x. Okay, so my y is actually h on this. The x was 75 squared. Calculate to solve, and I'd get 23.4. Okay, now we want to find the length of the brace. So we're trying to find this length of this brace here, this side. I know that this is a 90-degree angle, so it's a right angle. I know that this base side would be 75. And then this side, let me change my color, do a dash. That side would be 70 minus the 23.4 that we just found. Okay, so I can use the Pythagorean theorem now to find that missing side. Right, and the side that we're missing is our hypotenuse, so we will set the other two equal to that side. Take the square root, and we would get 88.3 for B. So that means that each of the braces need to be 88.3, and it is in centimeters. Okay, let's look at the try it. On a different satellite dish, the feed horn is 38 inches above the vertex. If the height of the dish is 22 inches, what is the width? Okay, so let's sketch this out. So they're telling us the feed horn is 33 inches above the vertex, which the vertex is at 0, 0. Here would be our feed horn. So our feed horn would be at 0.38. The dish is 22 inches, has a height of 22 inches. Okay, so that means this is going to be 22 above. So 22 above. Okay, so we're going to plug this into our equation. Our P is 38. Go ahead and simplify. Okay, they've told us our head is 22, that's our y, so we're going to plug in 22 for y. And we want to solve for x. Take the square root of both sides. Okay, simplify that into decimals. Okay, so that means that one of my x values, so this entire length here, is 57.83. Well, I need to know the entire width, so I'm going to double that. So my width would be 2 of those x values. So I'm going to end up with 115.66, and that is centimeters. So that means that the width is about 115.66.